Good morning, London. Hello, world. Welcome to Let's Code an Incremental Generator with Roslyn. I am Stefan Pölz. I love clean code, I love test-driven development, so we will be seeing a lot of tests today. I am a senior developer at Trayport, at the office in Vienna, but the headquarters is here in London that I visited also this week. Since a couple of months, I am a Microsoft MVP, which was very exciting. And also, for a couple of months, I am a JetBrains community contributor, which potentially will become positive for you at the end, so stick around. Also, I'm a co-organizer of the .NET Devs AT meetup in Vienna. We're doing user group meetups in Vienna about .NET. Since last year, I also stream at Twitch and YouTube under the handle /over. And on Twitter, I am 0x_F0 if you have potentially some questions later on that I can't answer later on at the Q&A session. All the slides are online. The example that we're building live, not yet. It will be. You can get there via /over.net/NDC London, but I'll be showing this at the end again if you want to check that out. So what is Roslyn? Roslyn is the .NET compiler platform for the languages C# and Visual Basic. And it also allows an extensibility model so that I, as a consumer of .NET, as a developer, can write plugins basically for that. I can write analyzers, which show bubblies, curlies, or you get warnings or errors in your IDE. You can also provide a code fixer, which then offers a Control-Alt or Alt-Enter experience depending on the IDE you are using in order to fix that problem. So it offers suggestions. You can also do a refactoring provider, which is basically a code fix without a diagnostic. So there doesn't necessarily have to be a warning. For example, if you change from block scope namespaces to file scope namespaces. And you can also do a diagnostic suppressor, which is suppressing warnings, not errors though. And since .NET 5, we can also write source generators. There's two interfaces. We will have a look at the latter because that has been added in .NET 6 and offers a potential performance improvement to the first iteration. Now I'm wondering who is consciously consuming some Roslyn components such as an analyzer in their projects. I see like roughly half the room. Who of you has actively already built something with Roslyn? For example, an analyzer or a source generator? 10, 15%? Okay, cool. I hope I got, for those who already have experience with it, also something new in store today. So when it comes to source generation, there has been, through the history of C# particular features been added. For example, the partial type, the partial keyword. And I want to specifically point out to the C#9 version of that, because in C#9, previously, we could only make, if we would make a type and a method partial, it cannot have an accessibility modifier. So it's inherently private, and it cannot have a return type, which means if there is no, a partial doesn't have an implementation, and if at compilation there is no implementation, nobody's providing it, not the developer, not some other tool, then this call to this partial method is actually is removed. So this is why it cannot have any return types or out parameters. And this restriction has been lifted in C#9 by explicitly adding an accessibility modifier. So if you're specific to a partial method, explicitly say, this is public, this is internal, now the new rules apply. And the new rules say, okay, we can have return types and out parameters and such, but we must have an implementation. If there is no implementation at compile time, either via manual write or for example, source generator, then this will be a compiler error. And we will use the partial keyword will be the center of our example today. Speaking of generators, so they have been added in .NET 5, and in .NET 6, or since .NET 6, the .NET team is also actively using them. So we will get source generators in the BCL. For example, in .NET 6, a system text JSON generator and a logging generator. And I want to show you the benefit of using that logging generator. So I have here a benchmark with benchmark.net and a logger. And here I basically set the minimum log level. So it has to be at least information or warning, and I run the tests with both. And if the log level is lower, then no log will be emitted. And I try to log via different variations. For example, the classic extension method via log information. Another version is to actually guard that log information level with a check if this log level actually has been enabled. And the third variant, this is the source generated version. Let's have a look at the performance output. So we see if so we log information, and if we actually do set the minimum level as information, so it actually gets logged, then we see that the extension method does allocate 46 bytes of memory. And also if it's if guarded, because the if guard will be true, so it's basically the same path. And without that if guard, if the log level is higher, for example, warning, so we are now, the minimum log level is warning, we log an information, so that doesn't get logged. If we do not have that if check, we also allocate 64 bytes of memory. But if we do have that if check, we don't. Why is that? There are some hidden allocations in this extension method. So if we have a look at the implementation, we will see that it takes a params object array. And what the C# compiler emits for this is actually an array instantiation. We don't see this in the code, but the compiler will emit this. So for every invocation, we will initialize an array of size 2. And also, we have a number here. Number is a struct type, a value type. And if we cast it to object, we will have boxing. And these are additional allocations on the heap. So it always makes sure to guard those invocations, because we spare those object array allocations if we do not log. And the source generated version is here. I have here a partial class, so that the source generator can actually add something at compile time to it. Then I have the partial method, which takes a logger and those two arguments, the name and the number that I have in this string format. And what the source generator generates, we can have a look at this. We see now in Rider, this is a very similar experience in Visual Studio. The file here has a bit of a yellow tint. This means it's generated. If I try to edit this, pop-up will appear and says, hey, this is a source generated file. This is actually not physically on disk, so I have to save this first in order to edit it. And the source generator, what it does is actually generate this if this log level has been enabled check for us. So we can, in this case, the source generator saves us performance and also avoids this tedious implementation. So our source code is actually cleaner because we don't have those manual if checks all over the place. And this is a very strong benefit of source generators. And I also want to show an example from .NET 7, which is a regex generator. So with regex, there is always a bit of performance consideration. If you always new up a new regex, that's rather expensive. Every new regex to invoke the first time is very expensive. You can set the compiled flag, which means then only the first is-match invocation is expensive and saves that call then to the assembly and reuses that. But still, that first call is expensive. And we also generate code at runtime. And with the source generator, all that code is generated at compile time. So we move, there's a lot of code. So we move that complexity from runtime to compile time. And the first invocation is as fast as any other because this is cached. And we don't have to write all of this ourselves to get high performance regex. So those are those two main use cases for source generators. They save tedious implementation and can also boost your performance. Now, what are the laws of source generation? The input of a source generation is actually the code that the user has written in this very project. So the entire all the C# files or the Visual Basic files in this compilation, so in the CS project, are an input to the source generator. The source generator gets this as the so-called syntax tree. What's a syntax tree? We can check that out via the site sharplab.io. And let's have a look at the standard code here. If we switch from C# to the syntax tree, now this is the Roslyn representation of this source code. So we are in a compilation unit, and we see this is this tree structure. Now we have a using directive, and we have a class declaration. And this class declaration has, for example, the public keyword, the class keyword. It has an identifier so that we can use it. In this case, it's C. And it can also have members. For example, a method declaration, which again has the return type is a predefined type, in this case void, and the identifier is M. And this is syntactic. This is to the rules of C#, syntactic. And we can also get meaning for that code. So if I write, for example, I want to return an int 32. Now, it says int 32, and I assume it's system int 32, but I could technically have my own implementation of system int 32. Well, this would cause an ambiguity, but I could have the same type name, which is actually totally different. But syntactically, it looks like an int. But semantically, it doesn't necessarily have to be. So the semantics is actually then having a look at this type. What is it? What members does it have? And this is then the second input that we can get from within the source generator. So we can ask the semantic models questions about the meaning of our code. The source generators can add many sources or no sources at all. And we add them as a string. So the output of a source generator is a string that then gets fed into the compilation, and then together with the already existing user code is compiled again. And this is where the partial then kicks in. So we have the user code's partial, the source generator's partial, and then they get compiled into one type, into one implementation of this method. Source generators are additive only. We cannot remove, we cannot alter code, we cannot rename anything. So we can only currently add new code to it. Since a source generator is technically an analyzer, we could also produce diagnostics, for example, warnings. Now there is of course a performance consideration with that, but we'll come to that a little bit later. Source generators are oblivious. That means if I have multiple source generators in one project, all of them get the very same input. A source generator, currently, this may change in the future, a source generator cannot depend on the output of another generator. All of them get the same input of this one project. And yeah, I mentioned the use cases, the typical use cases already. So tooling that I like to use, for example, is SharpLab, where you can have a look at a syntax tree. Visual Studio has a similar representation via the Visual Studio Syntax Analyzer. And there's also the Roslyn quota that I want to have a brief look at. This is basically the other way around. So I can put in C# code. Let's create a class. And then I see what Roslyn code I would need to write in order to get that. And this would look, let's enable the syntax factory. So via the syntax factory, we can create compilations. And well, this is somewhat helpful to source generators perhaps to understand the structure. This is very, very useful for analyzers and other models.
What did you call that website?
the Roslyn quota, but all of this is on GitHub, so you can have a look at the links later on. When it comes to versioning, since there is many versions of Roslyn, I created a little bit of a matrix. If I find it, there it is. So we start with Roslyn 3.8. This is the Roslyn version that is included in the .NET 5 SDK, which means if my source generator is targeting Roslyn 3.8, the consumer must at least have the .NET 5 SDK, so the first was like the gold release, version 1, after the release candidate has been released. If I want to use additional features, for example, in 3.9, post-initialization has been added. We will have a look at it, what this means. And if my source generator is targeting 3.9, the consumer must have the .NET SDK 5.0.200. So depending on the Roslyn version I target, the consumer of the generator, which then invokes it and produces code, needs to have respectively a higher version of the .NET SDK. And I also list the compatibility versions with Rider if you want to have a look at this later on. What we will be using, since we will be using post-initialization, we will also be using the incremental generator because they offer potentially a performance boost over the classic iSource generators. We will not be using with tracking name. This isn't directly helpful for the generator per se, but if you have tooling that runs the generator, you can produce some more diagnostics with that. There was also a bug in the previous version, which is fixed in 4.2, and in 4.3, which is the last release of within the .NET 6 SDK timeframe. A new method has been introduced in order to analyze where the user is using specific attributes, and we will gonna make heavy use of that. So now let's jump to the live coding example. The example that I would like to build, how I started here is actually I built a template for source generators, and basically what I did in the morning is invoking this command via .NET New. This template is available on NuGet if you want to have a look at it. It contains the source generator, it contains tests, it also contains benchmarks, and you can then rather easily, there's not much more you have to do in order to publish then this source generator as a NuGet package, if you find that helpful as a kickstart. Which is this project, f0.templates, also available on NuGet. But yeah, the link is in the slides if you want to check that out later. So let's jump to the example that I would like to build. So, as most of the times, when it comes to source generators, I start with a benchmark. So, what I had a look at is the enum is defined. So, enum is defined, basically checks we have an enum, in our case here the logging enum again, and we can check if that value, when we pass in a value, if this is part of the enum, if there is a constant defined with that value. Because if we check out the log level enum, which is part of Microsoft.extensions.logging.abstractions package, we see they have values provided. And we can, since the underlying type of an enum per default is an integer, we can assign any integer to that enum. So let's have a look at a test actually first. For example, if you had a test, I start with -1, and the values 0 through 6 are actually defined in the enum, but 7 again is not. So is defined should return false. And this test confirms that it works. Okay, I give it away, the generated version, but for the BCL version, enum.isDefined, this is how it works in .NET Framework. the generic version doesn't exist yet, so we need to use the type of overload. And if we run that benchmarks, and since enum.isDefined is using reflection under the hood, there is a bit of a performance hit. And what if we theoretically we had a generated version, which is a little bit more naive, but does it more direct without reflection? What would the performance difference be? And in our case, so this was the test, sorry. Let's have a look at the benchmark. So at the benchmark, we run the BCL version. We run a hand-rolled version. This is the naive version I meant. So we basically have just a value, and we check, is it trace, is it debug, or any of those 7 values from 0 through 6. And if it's not, if it's -1 or any other integer, then it would return false. And the performance difference between these is measurable. So the BCL version has 15 nanoseconds, and the hand-rolled version is barely measurable because it's rather naive. It's just checking some integers. And so this hand-rolled version, the downside is this hand-rolled version only works for log level. So this only works for log level. I cannot use it for any other enum. Where isDefined, I could use for any other enum. So again, it would be very tedious to implement this hand-rolled version for every enum again. And if that enum changes, if somebody adds a value, then basically the hand-rolled version could be invalid. So wouldn't it be cool if we had a generator automatically doing this tedious work for us? And this is what we will build now. Before we really start, let's have a look at the CS project. Because it's important that the source generator is targeting .NET Standard 2.0. This is because there is various toolings out there. There is Visual Studio, which still runs on .NET Framework. Wider's backend is running on .NET Core or .NET. So we still need to target .NET Standard 2.0 in order to make this generator consumable from any tooling. I do multi-targeting with the latest target framework in order to get nullable reference type annotations. So there's a little bit of a trick. This is then not part of the NuGet package, because if we have a look then later on, we will only pack the .NET Standard 2.0 version. There is a trick. This is Microsoft actually does multi-targeting with different Roslyn versions, but I couldn't figure this out yet. So currently we target one version, and it must be .NET Standard 2.0. And here I suppress the nullability warnings for .NET Standard because .NET Standard 2.0 was C# 7.3, and there are no nullable annotations yet, which have been added in C# 8 and have been introduced with the .NET Core 3 SDK. And more annotations have been added, so the question marks and various attributes for reference types. And I ignore them for .NET Standard, but for the .NET 7 build, I use them in order to get the warnings, to get the nullability right. So let's have a look at the interface, the incremental generator interface. So our generator has to implement this interface, and there is only one method, the initialize method. And from that, we build a pipeline. And this pipeline approach is the huge difference between the .NET 5 iSource generators. And with this pipeline approach, we will see that at the end, we can short-circuit separate steps in order to avoid duplicate work if it has already been the same as the previous one. We will see the benefit at the end. So when we start, we implement the initialize method, and I mentioned it before, there is post-initialization. And post-initialization actually enables a bit of ordering. So we can actually, code that we produce in the post-initialization phase of the generator can actually be used in subsequent generator phases. In the general output phase, in our case. So this is how actually we can generate source, which we later on depend on. And in this example, I am putting out an attribute, the isEnum defined attribute. This is actually a C#11 attribute. You see, this is a generic attribute, which also takes a type, and this type must be an enum. So it must be a struct which derives from enum. We can't manually derive from the enum type because structs cannot derive any other classes, but in .NET, so the .NET team knows how to do that. It's part, I'm actually not sure, but so this is a check to know this is an enum, yeah. And I want to apply this enum to a class, and then on this class, on this partial class, I want to emit those isDefined methods. So I'm marking a class for the generator to observe and create the relevant implementations of the isDefined there. It's always good practice to add the auto-generated comment at an auto-generated file, so that tooling knows, oh, this is auto-generated. For example, an analyzer. In analyzer, there's a flag if you also want to analyze auto-generated file. By default, you should rather not, because the user has no direct influence on this on the generated file. And if this would produce warnings, and if the developer had warnings as errors, this would be very annoying. Cannot actually fix that. He would need to fix, or they would need to fix the generator. If they don't have source access, that's troublesome. And also, I like nullability, so I always enable nullability, because in generated files, the default nullability context is false. There are no nullable mutations. Then, it's another good practice to add the generated code attribute. I define it up here. Generated code attribute adds the name of this assembly and also the version. Again, this is for tooling. This is for not source code based tooling, because the comment may not be emitted in the metadata of the assembly, but for example, reflection based tooling would be able to read this attribute and know, okay, this is a generated file, I should treat this differently. And we're putting this in the Roslyn.generated namespace. And now, this is actually what we have. So if we run the tests while having a look at them, I am here again defining this attribute that I'm checking against. We see this is all strings, because that's the output of a generator. And I have here a test if I don't have any candidates. So this partial class does not have this new attribute applied, then nothing should be generated, except this one is enum defined attribute. This is not necessarily the best practice to emit those marker attributes also via source generator, because if we have multiple assemblies using the generator, now we have this type. It's an internal type, but still we have this now in multiple assemblies. So you could also produce this marker type, this attribute, in a separate assembly, in a separate NuGet package, that then the generator is also automatically including, and you only have this type once. But for our case, this shows how the post-initialization phase works, because we are first outputting this attribute, and then later on we can search it. And this is now the second test. We see this is now failing, because in the second test we actually want to use that is enum defined attribute. So we can now depend on it, and if we find that, now I want to output the code. So this is now what should be generated, the partial class again, and now there is defined method with, in our case we're using string comparison, because this is what we defined up here, and now emit all the enums for that, doing the OR check, all the enum constants, and then doing basically string comparison and check, has this really been created? I do have here a bit of a name. It's the is enum generated.g.cs. So if you have a generated file, always add .g.cs or .generated.cs. Again, the tooling knows, or the reader knows, okay, this is generated. But this is not necessarily a file. Per default, those source-generated sources are not put to disk. There is a MS build flag that you can set, and also a directory that you can put to actually see on disk what gets emitted for debugging purposes perhaps. But by default, this is just a hint name for tooling to show, but it's not necessarily put to disk. It's not necessarily a source file. Now our test is failing. Let's have a look why. Yeah, because I haven't implemented it, great. And so let's get to it. Since we want to search for this enum type, perhaps let's have a closer look how this looks in the syntax tree. So if we go to the test, if we grab that example, go to sharplab.io, put this in. Now it doesn't compile, but we can still have a look at the syntax tree. We are searching for class declaration that have in their attribute list this very attribute. And in previous version, it was rather manual. In order to search for that, you really had to drill down, have a look at all the class declarations, see if their attribute lists contain this very attribute, and basically had 2 for each loops in order to search for it. And with Roslyn 4.3, sorry, a very nice feature has been added that does that for us. And I guess also the most performant way, because the Roslyn team, they know what they do. So we can write on the syntax provider, we can write .for attribute with metadata name. And now we provide the metadata name. I have the is enum defined attribute metadata, which looks like this. Perhaps you have seen this in reflection already. When we have a generic type, there is this backtick 1, which indicates this type has one generic argument. If it is a backtick 2, it has 2. And this is why we can't overload by generic differences. So we can't have an overload with one generic type parameter with different types, because in metadata they look the same, so we have an ambiguity. Now we're searching for these, and then on this provider we have 2 more callbacks. We have a predicate. We see the input for that predicate is a syntax node. So we get in each and every syntax node where this attribute applies to, where this metadata attribute has been found on. So we can do further checking. And then we have the transform method. And this transform method now is semantic, because in this generator attribute context, we not only get the syntax node, because the syntax node, as the name says, it's syntactic. We know what it looks like, but we don't know exactly what it is. But we also get this target symbol. In this case, where the attribute has been applied on, in our case, the class. The symbol is semantic. It has type information. And we also get the semantic model. So we could ask additional questions about the meaning of the code. And we have a collection of attribute data. So we could apply this attribute multiple times in order to make multiple methods. And we see that's an immutable array. In Roslyn, almost everything, if not everything, is immutable. So if we have a syntax tree and if we edit the syntax tree, this will be an entire new syntax tree. I think this is how you enable basically Control-C experiences that you can go back to previous steps. And this is how immutable array is used. You cannot, an immutable array is a struct which has an array under the hood, but you cannot modify that array. And now we will use the predicate, the syntactic check. We get in a syntax node. Oops. So let's say node. We also have a cancellation token. And let's see if this is really a class. Well, on the attribute, we declared that this attribute can only be applied to classes, but still, let's make sure that this node is a class. So predicate must return a Boolean, so we return if this node is a class declaration syntax. Again, how do I know how this is a class declaration syntax? Because in SharpLab, if we have a look at the syntax tree, we see that this class is a class declaration. And that's the type that we can check for. And what I also want to check is that this class indeed is partial. Because if the class isn't partial, we cannot add source to this type. So we need to make sure that this is partial. So we can say class dot, oops. Oh, I should add a end. If I make some errors, I have my Webber debug here to help me. But if you spot any obvious typos, please let me know. And we can go for the modifiers and ask the modifiers if, sorry, I have to cheat. Because that's the, oh yeah, we're right, we use any, actually only, there's an extension method, yeah. So we can ask if the kind, if the partial keyword is a part of these modifiers. So the modifiers includes the for example, public on a struct read-only would be a modifier, or the partial in this case. And we see if any of these modifiers is partial, and only if this predicate returns true, then we go into the semantic check, the transform. Now the transform, we see, oops, that must be a comma, sorry. The transform receives a context. Again, a cancellation token.
Yeah, an extra closing.
Right, thank you. And here we can, again, ask additional questions. I grabbed that from the example and walk you through. So, since we checked here that this is a class declaration, we can cast this into the class declaration syntax, denote. If I would cast it to anything else, it would crash, and then the source generator crashed, and no sources are output. So always make sure that it's safe in generators, because it's not, when a source generator creates an error, it's not super obvious. It just doesn't work, and it's then, especially if it's a NuGet package, rather hard to debug. So always make sure that casting is actually safe. And so we know that the syntactic information is a class declaration, and with that we know that the semantic type is a named type symbol. Now we can safely assert that our attribute list has at least one member in it, because this is what the for attribute with metadata name is doing. It ensures that this metadata named attribute is actually applied at least once on this syntax node. And then we return this in a tuple. And from that, we now go on. Now we build up the pipeline. So how does this pipeline work? Let's have a look again at the syntax provider. The syntax provider and the for method returns an incremental values provider. There is two of these. There is the incremental values provider, plural, and there is the incremental value provider, singular. An incremental value provider has one thing. Values provider, multiple, or 0 to many. So that's then later on an immutable array. And we have more of these. If you have a look at the context that we get in to the initialize method, there is many of these value providers. So we have, for example, a compilation provider. We can have a closer look at the compilation. There's only one compilation, so this is a value provider. We can also have a look at the options of the compilation. We can have a look at the parse options. The parse options, for example, would include with which C# version this project has been compiled. So you could technically, depending on the language version of the user of the project, emit different codes to be more compatible, technically. There is also additional texts. Additional text is anything that is not C#. So I could have a text file, an XML file, a JSON file that I transpile into a C# source code. Not every additional files, like a JSON, if we have a web project, there is the app settings.json. This is not per default getting in. You have to explicitly mark in the CS project, mark that file as an additional file. And all additional files then will be visible to generators, analyzers, to all the Roslyn tooling. And there is also the metadata reference provider that I mentioned that had a bug. The bug was that before version 4.2, this was a value provider, not a values provider. And the metadata references, for example, are the assemblies that this project is depending on. For example, newtons of JSON or other NuGet packages. And we can also not only have those basic providers, we can also chain providers with link-like methods. For example, because what we have here now is we have the class declaration, but we have multiple attributes. Now what I want to do, because there is one test which actually, I thought I had this test, but we could actually apply the same attribute twice on a type, and then we need to emit two methods. And for that, we need to now group these. So I'm doing now here a select many. And there is my mistake. And now basically fanning out those multiple attributes, this attribute data that we have, and combine this with the type information and with the syntactic and the semantic information of this type that this attribute has been applied on. So this is how we do a select any. We create an array with all this data and then return this data. So we now switch from one single output to multiple outputs. Now, we will do a step that will come in handy later. We will now select those elements that we need in order to generate the source code. So we will drill down and get all the information. What do we need in order to emit this code? Let's have a look. So we need the namespace that this type is in. We need the type name that this attribute has been applied on, so because we need to mark it as partial in our added source. We need to know the enum, so not only the name of the enum, but also the semantic information of this enum. So we need to know that this enum has those 6 constants, the current culture, invariant culture, and so on, so that we can then emit this source code. And we will grab all this information. So we ask the symbol to get the containing namespace and see if this is the global namespace. Because if it's in the global namespace, there's also a test for that. So we could declare a type which isn't in a namespace. And then we can't emit any namespace. If we would try to get the namespace name of the global namespace, it would be global namespace in brackets. And this would be invalid C# code. So we need to check for that. We also then get the name of this namespace. We get the name of the type. We get the name of the enum. And I'm using here a format, the global alias format, in order to produce this. So it's good practice in source-generated code to always use the global alias in order to avoid potential ambiguity. So the user could declare their own system.string comparison, or could declare their own in a different namespace type from the BCL, and with that we can potentially avoid these errors. So it's rarely, I saw rarely that there is actually a using declaration in source-generated code. So we need the full name with the global identifier, the global alias, and also now we need to get the members of this enum. We do that by getting the members. And we need to filter for all members which are a field. Because per default, this is how I learned while building source channels, this is how I learned a lot about C#, because an enum actually has a default constructor. So if I would go, where do we have a test? For example, the log level. I can write var level equals new log level. So there is a default constructor for enums. Now, be aware that if there is no zero element in that enum, for example, if we start at 1, invoking the default constructor would still assign the value 0 to it, because the underlying type is an integer, and by default an integer is 0. So this is how we could, if we don't have a 0 value, the default of an enum already would not be defined. And in order to get rid in our selection of this default constructor, we will filter only for the fields. And then we convert this to the string. Again, we say toDisplay string, which allows passing this alias, where we say, we can have a brief look at this. This is basically combining various enums in order to say, okay, use special types. So if it's actually saying the language keyword int, keep it as int. And we include the containing type, and also is the global. The global is part of this fully qualified format already. And now we have all the variables that we need. Now we can create the source. But I still have a compiler error. So what do we have? Excuse me?
You've got context used twice. Scroll up. Going context then you change. Context is just outside the lambda.
Right. So let's make this. This is why I usually actually also always mark them static in order to avoid these errors. Thank you very much. And I guess I also have a bracing error. Yes. Okay. And now we created this pipeline. So we have selected and filtered, and now have this one provider, which has now, if we have a look at the type information, this is now an incremental values provider of this is enum defined info. So we have multiple of these. Now we can get to generation. And we also do that via the context. So we can say context dot, actually have it down here already, register source output. If we want to produce diagnostics, we could also do it via context dot report. Oh no, it's not. Ooh, it's down there. Sorry, I confused. Yes. So now we register an output that acts on this pipeline that we have built. So let me bring that in. Oops, what I forgot is to also collect, because we now have an incremental values provider. And if I want to change an incremental values provider, which is multiple, into a singular, we can say .collect. I'm doing this in order to be able to put all, because in this example, I want to put all the source into one generated file. And so I collect this into one. Now we have an immutable array, and now we can put this into one single file. And now let's bring in the source code, which actually generates the source code. So I'll walk you through. So we will get as an input a source production context, via which we can actually add sources, and we get the result from our pipeline that we built. In our case, since we have collected, we get an immutable array of this type. If we wouldn't have collected, we would get just the is enum defined info singular, but then it would be invoked multiple times. So we could produce multiple files, multiple sources, but I want to merge it into one, so this is how I collect. Then, since we are creating a source, I start here with a string builder. I wrap this in an indented text writer. This is how you can do easily indentation. Always add, good practice, always add the auto-generated header and nullability information. And now we iterate through all the infos that we have. We check, are we not in the global namespace? Then we can print namespace information. If we are in a global namespace, we don't say anything about the namespace. That is per default in the global. We print the partial class. Now within that partial class, here we do indent in order to get nice indentation. This helps having a look at the code later on. Then we emit the isDefined method with the name of this enum, which is the global : version. Then this enum could be empty. So we could have an enum without any constants, then we just return false because no value is defined. If there are any constants, then we start emitting this return statement. So we return value is, and then for each constant, we write the constant and or combine it. And if it's the last, we just write a semicolon. And then we close our brackets. So we close the brace, close another brace. Then at the end, we again need to check, are we in the global namespace? Because if we are, we open the brace. We need to close it now. And then we build a big string and put this to disk. And this is where the actual emission is happening. This is where the source code is added to the next step of the compilation. We give it a hint name, and the hint name now will come in handy because tooling will show us where it is. So if we build that, and have a look at the example, hope that everything turns not red. We can have a look in Rider. This is very similar in Visual Studio. If we drill down to the framework that we are compiling with, there is a source generators folder. Here is our source generator. And there we can have a look at those generated files. And these not files, but sources, these are the names that are used. The hint name is used for that. So we can have a look at the attribute. There it is, it's valid C# code. And we can have a look at this enum that we define. And here we have it. We have successfully emitted the headers. We have, since we've been we are not in the global namespace, we have a namespace, we have the partial class, we have the log level, and so on and so forth. And now we can actually run this example, and we are searching if log level.trace is defined, the output is true, and if we would try to say -10, cast this into log level, wondering what I'm doing wrong. Maybe let's put this into a variable. Level. What am I doing wrong?
It's like levels int. So you might have to say log level, like instead of var.
Excuse me?
Looks like var is giving you an int for level.
Yeah, I'm not sure. Do you know why? I need.
Brackets around the right side.
Oops. Enum name is not valid at this point. Did I forget how to cast?
Do you put brackets around -10 to try to do log level -3?
I did forget. Oh, is it the negative? Okay, I did. Okay, I did forget how to cast. Okay, and if we run that, we should get a false. And there we have it. And this is now the faster version. So this is now, if we have a look at the full benchmarks again, this is now the generated version, which is equal to the hand-rolled version, because the very same code has been emitted. This naive check of just checking if any of these values is the value that we got in, any of these integers in that case. But we didn't have to actually write it. So if this enum would change, the source generator would actually update. Now speaking about updating, there is still one thing to left, because currently we not really use the incrementality of this generator. We just built a pipeline, but we're not using its benefit just yet. And I want to show this by going back to the generator, and at the top of the source, let's write a comment that prints the current datetime. If we build that, and have a look at the example, at the output, put these next to each other. Here's the program. Now we have 11:14. Time is running out. If I hit return, just somewhere, now the source has generated. Source has been generated anew, 15.40. But nothing really has changed. Nothing relevant has changed. We didn't add, the enum hasn't changed. The type, we didn't add another attribute, we didn't remove an attribute. Nothing relevant has changed. So we create the same output again. And this is now what the incremental source generator's power is for. And this is by comparing. So I'll be adding now a comparer within the pipeline. So let's jump to the pipeline before we collect. We have here a comparer which compares all of these elements, and for the array does a sequence equal. Because this is actually what the default equality does, equal just all the members, but then array isn't per default sequence equaled. So this is how we need to do it manually. And if we rebuild that, now we actually have the incrementality in place. So if we understand that after the comparer, the output of this generation phase was the same as the previous one before we hit enter, then it basically stops and reuses the previously emitted output, what has been cached, and we don't go into this method again. And the evidence is here. So if we have a look at the generated file on the right hand side, and if I now hit enter, the 11.16.28 should not update. And it doesn't. But if I add another attribute, if I actually change something relevant, which is mentioned in the pipeline and mentioned in the comparer, let's add a string comparison enum here. And I'm not even building it. This tooling now automatically regenerates it. We have a new time, and we now also have the string comparison is defined emitted. But again, if I remove some code which is not relevant to the pipeline, it will not update. And this is the true power of the incremental generator and the pipeline that we built. So we need to build our pipelines efficiently so that caching can be used. And this concludes the example. Here's a list of the best practices. We went through all of them. And yeah, if you want to get started, all the links are online. I also put some more examples. For example, the community toolkit. This is recently and continuously updated with source generator improvements, recently with a lot of performance improvements. For example, they moved the diagnostics from the generator to an analyzer in order to make the generator faster. I also have additional references and videos if you want to know more about generators. And now there is 2 minutes left for questions. What I mentioned at the beginning, for the first 2 questions, I got 1 wider license for you to score that I was given by JetBrains.
Short question. When you were showing the IDV comparer, Your type is a record type, right?
In that case, I use the record type.
Yeah, so it should be able to compare all the properties by...
Technically, yes, but we have an array.
That's not the array.
The array equals array does not do a sequence equal. And it's a struct, it's a value type, so it's barely ever equal.
So you wouldn't need that comparer if, say,
If you didn't have a collection.
yeah, if it was just a normal record that could compare
Yes,
with-
yes, because the default comparator that is used is is it comparator.default, if that exists? Yeah. So there is a default comparator in place which just does the iQuotable.equals invocation, or the object overload if I equals isn't implemented, and that's the default. If we have something special to do, in our case the array, we need to write a custom comparer. I think Quentin was next.
I actually had the same question about
Okay.
using records. Yeah.
Then
Could you comment on the rider versus Visual Studio support for source generators and source analyzers? Because we rider, and we were wondering if you would need to use Visual Studio because we want to use these features.
I was using Rider because it both have the advantages, both have the disadvantages. I'm using Rider because you can actually build it again, and then I don't need to restart Rider, and the new source generator is picked up. With Visual Studio, if you change the source generator, because it's loaded at startup time of Visual Studio, you need to restart Visual Studio if you change the source generator. So this is for the actual integration part. There's also unit tests. For the unit tests, you don't need them because the source generator is loaded in memory. And I also link it in the slides. So the unit test framework that I'm using is also from Microsoft, which is Microsoft.code analysis. Everything Roslyn starts with Microsoft.code analysis. C# source generator does testing. And for that, you don't need to restart Visual Studio. But for the actual deployed version, if you have the source generator in code, then you need to restart it. The advantage of Visual Studio is debugging. There is a feature that you can actually have F5 debugging of a generator. You can't do this in Rider. But since with unit tests, you can debug via unit tests. So if we jump to any test, let's have put our breakpoint anywhere. Go to the unit tests and debug it, then we will land there. But if you have loaded it as a component, as a NuGet package, then you can't debug it. So those are the two biggest differences that I saw. But everything else is similar. You can develop all of them. Both of them offer you can drill down in. So we did hit the breakpoint. This view here is also available in Visual Studio, and other than that, they're quite comparable. Yes?
I know we're over, but one tiny question. So when you use generated code, one of the annoyances is if you want to go to declaration and it's being done by a source generator, then very often it isn't found. Do you have any workarounds for that?
This works in both Visual Studio. Both Visual Studio and Rider are aware of that. So if I F12, that is defined. I hit F12, and I select because I do multi-targeting. I now select the framework, and I jump to the generated code. So both Rider and Visual Studio, you can do F12 into generated code with both Rider and Visual Studio.
Oh,
It just sometimes misbehave, but generally it works.
that doesn't work for me. So maybe I've got an old version or something.
Perhaps.
Really talking about
Try restarting Visual Studio.
Maybe, yeah, it may be Visual Studio, yeah.